This is section 3.8, number 35, and we are doing implicit differentiation, and they want dy dx. It's important to know that because that tells us x is our variable, y is our function. So you have to realize we have a function here and a function here that's not a variable. So we have to take the derivative of both sides, and I have e to the box. If it were e to the x, that's easy, e to the x, but it's not, it's e to the box. That is chain rule. What's the derivative of e to the box? That would be e to the box times derivative of box. So I need the derivative of box, but what is the derivative of 2y? Well, 2 is a constant and y is a function, so the derivative of that is just dy dx. Plus 1, I like that. Derivative of x, just 1. And the derivative of y, because it's a function, is dy dx. So I'm going to isolate dy dx's. So far, so good. I'm going to rearrange this one. I'll explain what just happened if you're confused. So these are all being multiplied. And you learned that multiplication is commutative and associative. You could rearrange in any order you want. So I just put the 2 and e to the y first. Now I'm trying to isolate dy dx. So I will end up with this, and I'll explain what's happening also. What just happened? I want to get rid of that because it doesn't have dy dx, so I subtract 1 from both sides, so that's why there's a negative 1. I want all the dy dx's on the left side, so I subtract that from the left side and the right side, so that's why it's there. My goal is to isolate dy dx. I notice these both have it, so I can factor that out. So we get dy dx is, nope, parentheses, I don't know why I did that. dy dx parenthesis 2e to the 2y minus 1 equals negative 1. Now understand, factoring is backwards multiplying. So to double check, that times that better equal that, and it does. That times that better equal that, and it does. Some people forget the minus 1 thing, and oh, I took it out, it's 0. No, it's multiplying. That times that equals that. I need the minus 1. So divide both sides by the thing next to my dy dx, and there is dy dx. Oh, this is beautiful. Something beautiful is going to happen. Now we need to take the derivative again because they actually wanted a second derivative. I was a liar, liar, pants on fire. We want that. So we need to take the derivative again. Now the derivative of the left side, that's easy. The derivative of the derivative by definition is the second derivative. I can do that. Now, people might do the quotient rule. That's what the rookie would do, not realizing I don't need the quotient rule. I think I told you guys earlier, it may not have been in this class, if you ever do a quotient rule and one of your things is a constant, you are wasting your time. You should rewrite this thing. How do I rewrite this? Okay, again, you don't see it, but there is a parenthesis there. Because of this fraction bar, that's all stuck together. And you also don't see it, there's a 1 there. So I can move that to the top. It becomes negative 1, 2e to the 2y minus 1 to the negative 1 power. If I move something to the top, the exponent changes signs. That's why there's a negative 1. All right, so this becomes not so bad to take the derivative. This is box. You're going to use a power rule. X to the negative 1 power, you move the negative 1 in front and subtract 1 from that. I'll copy this constant. So that constant goes with it. I bring the negative 1 to the front. I leave box. And I subtract 1 from the exponent. That becomes negative 2. So once again, what happened? The negative 1 moves in front, subtract 1. So it's negative 1 box to negative 2. times the derivative of box. I am missing the derivative of box. Let's do that. What is the derivative of this? So 2 is a constant, so I copy that constant. And what's the derivative of e to the 2y? Well, again, that's e to the box. What's the derivative? Whoa, that was what's happened. What's the derivative of e to the box? I am my own grandpa, so it's e to the box times derivative of box. But the derivative of 2y is 2 times the derivative of y, which is dy dx. That's the derivative of box. And the derivative of 1 is 0, so we have a 0 there. It's all starting to look beautiful. Are you ready? Nice things happen. 2 negatives make a positive. I like that. I am going to make a fraction. So watch this. Negative exponent, it moves to the bottom and becomes positive. So I'm going to get a 2e to the 2y minus 1 squared. And what do I have left on top? I have all of this. So I'm going to move that here. 2e to the 2y times 2. Well, those two 2's will make a 4, right? 2 times 2 is a 4. And then I have dy dx. And here's where your algebra skills will come into play. Wow. I'm not allowed to have that. I want x's and y's. I don't want dy dx's. So I look up here and I say, hey, I can replace that for dy dx. But I'm about to make your life easier. I'm going to write this differently. See if you know what? Let's do it like this. I claim this is the same as this. Do you agree? Hopefully you do. Because this times this is just that. Okay? So if that's true, we're almost done here. And there's a reason why I put it to the side instead of on top, and you will see. Un momento. So I'm going to replace this with its equivalent. What is the equivalent? We found out it equals that. So let me copy, paste that here. So I want to replace this with that. So let me get rid of dy dx. And let me slide this thing over like that. And let me parenthesize this so you don't get confused. We're done. Look, negative 4 e to the 2y over, we have 2 being multiplied. We multiply a third one. That is a cube. Cube. Bam. That is, I like that problem. It is beautiful. It ends up being very